first semester, we have only continuous assessment. Section 1 weight 40%, and Section 2 also weight 40%. In Section 1, we have 2 tests, and in Section 3, and in Section 2, we have 3 tests. The practical is 20%, and the practical is done via video, like the one you did for the machine 1. So the class mass is calculated as 40% Section 1 plus 40% Section 2 plus 20% practicals. So students who cannot make 50% for the class mass, we have to do a catch-up test, and a catch-up test is 50%. So for practical, we are going to open the slot for you to submit your pre-prac, and we are going to upload the video for you to do the post-prac. So information are clearly indicated in the handout that is on the Moodle.
Oh, okay.
Is it understood now?
Yes, I understand.
Hello, good afternoon, good morning. How are you? Can you hear me? Hello? Hello? Hello, can you hear me? Put your microphone on.
Yes, we can hear you, sir.
Either if you don't put your microphone on, or if you don't say anything, I want to know. Can you see the screen? University of KwaZulu-Natal, School of Engineering, Power Systems 1, course outline. Can you see it?
Yes. Yes, sir.
Okay, thank you so much. I'm so sorry about being a bit late. I just what happened, the microphone was not being picked up on my system, so I had to restart and do everything from the scratch. So what I'm going to start now. So you must not keep your microphone off all the time, because I need to listen to you of what you are saying and all those. Okay. You must respond. If you don't respond, I will not be able to continue. You must put your microphone on.
Okay.
Hello.
Yes, sir.
Can you listen to me? Put your microphone on.
Yes.
Okay. Thank you very much. Thank you very much for joining this session. I'll go through the course outline in details. I couldn't hear what Dr. Tiako has mentioned in the course outline. There are a lot of things that you need to consider in this Power Systems 1 module. So I'll go through each of them in one by one manner, and if you have question, you must ask at the same time. Okay, so what you need to do is that keep your microphone on all the time, and I must listen to you. If I don't listen to you, I'll stop there. It will not continue. So as you see, that is the Power Systems module, and we have a number of Power Systems module in our discipline, electrical engineering. And when I say number of modules, we have Power Systems 1, After that, we have Power Systems 2 module, and we also have another module which is called Power System Stability. So I'll come to that one in one by one manner. So can you see the second slide now? Course background and purpose.
Not yet, sir.
Eh?
No, not yet.
You can't see it. You can't see the course background.
I think it's my network, so let me just try change to my phone quickly.
Can anyone else see the screen course background, or should we go to Zoom?
Yes, I can see the course
We can
background.
see.
Then
And
if you can
papers.
see when I'm asking, please respond to that, because it will otherwise waste time. That's why I was saying that you must keep your microphone on all the time and respond to what I'm saying. Okay, so the course background, this Power Systems one, we have said that there are 3 modules in our electrical engineering related to Power Systems, Power Systems 1, Power Systems 2, and Power Systems 3. The first module we are coming across it's in third year. It's Power Systems 1, and it's a 16 credit module, and it's in electrical power system. It's a very big module, and not only that, it has a lot of things that are in this module that we need to learn and apply them in our real life being an electrical engineering. So this module is a very, very important one, and if we don't learn it, then we will not become, at least I can say that we will not become a complete electrical engineering professional. So we'll have to remember all this time what we are doing in this module. Not only it's a 16 credit module, and there are a lot of things we need to learn all of them and apply them in our real life when we will become engineering professional. Now, talking a little more on that 16 credit course, this is very important to take note, as you know it already, that this is 16 credit course. Some of you register for less number of credits in a semester, so for them it's even more serious, because when you are on probation, you need to meet those probation requirements, and if you don't meet them, then it becomes very difficult in the following semester to come back and register yourself as a student. Now this 16 credit, like for example, if you are registered for 64 credit, then this 16 credit will become 25% of the number of credits that you have registered. Does it make sense? You must respond.
Yes, it makes sense.
So it's 25% of 64 credits. If you fail this module, it means you failed 25% of credits that you have registered for. That might cause some impediments in your progression and deal with all those consequences. So you need to be very careful in that regard as well, apart from learning and teaching and applying them in real life as an electrical engineer. Now, this second bullet point is talking about the aims of this module. We used to introduce the fundamental principles that are related to large electrical power systems. Now, from first year, second year, you have worked with some electrical systems, maybe some electronic systems as well in various modules and in practicals, but these power systems one module is mainly related to very large power systems, meaning, for example, we are in South Africa, we can talk about Eskom power system, meaning it connects from the power generating stations that are located in various states. Like for example, in Cape Town, you have Kubag nuclear power station. We have a lot of power stations in Mpumalanga and so on. So those are the part of these module, along with the transmission lines that we put to transmit power from those power stations to the consumer premises, to the consumer premises, meaning the consumers are also part of these power systems, including transmission line, and in between transmission line and consumer, we have distribution systems. So the distribution system is also included in this one. So there is a lot. Even if you spend your whole life or one spends his or her whole life in power systems, it cannot be said that I have learned something. It's too little time to learn the aspects that are covered in power systems. So it's something that is huge and that is related to large power system, not small power systems. And the third bullet point is talking about the broad scope and preparing the students with a range of topics or the chapters that we talk about, and it is related to high voltage engineering, or also it is related to machines, because when we study something like high voltage engineering, something like machines, they are separate modules. They can work independently, like testing and insulation on a transmission line, testing insulation of a generator, testing insulation of a transformer. But that transformer or a generator or even a motor wouldn't work. Testing is that testing part, but that transformer, that generator, that motor has to work. When you need to get them working, meaning you connect them in a system, and that becomes a power system. So you need to know those things as well. So it becomes that much complicated when you put them in a system to serve some purpose, definite purpose. It's not like just I'm done with testing of a generator installation or a motor installation or transmission line installation. I have to make the transmission line working for transmitting power. I have to make the generator working to generate electrical power. I have to make the motor working to consume electrical power and produce mechanical output power. So that is the level. So if you don't understand those machines, those insulations, generator, motors, it will be a bit problematic. And power system combines all those. Other modules don't. We need all. We need generator, we need motor, we need transmission line, we need distribution lines and everything. So that is the in-depth aspect, and the broadness of it lies in there. It's very important to take note. I'm going to the next slide. Such systems, large systems, AC systems and DC systems. And in this module, we are focusing on AC systems only. We are not focusing on DC systems. So the DC systems will come in some special modules like power system stability or some other modules as well. So we need to learn those theories for various reasons. Like we said, we need to learn the basic operation of the system, how you operate them. And when we operate them, what are the things that we need to focus on, or we need to check, we need to monitor, we need to control. Those are the things like power flow, how the generated power is being transmitted or flowing through the transmission line and distribution systems to the consumer's premises. Like my laptop is connected to, for example, literally to one of the power stations. I don't know which one. Is it in Mpumalanga power station or a Kubak power station or a power station in Drakensberg? So we need to control those like power, voltage, load, meaning the demand. The consumer premises have the electrical loads that are consuming electrical power, but we can control them, meaning we have a load shed. We don't want them to consume electrical power anymore because we have a situation now. And sometimes we do something called power factor correction, and that power factor correction is also very important in terms of operation, in terms of maintaining the system in an effective way. Right. So the next point talks about the analysis and solving the power system networks under fault condition. Meaning when we have a system, there might be a fault. For example, you are driving a car, the brake might not be working, the clutch is not working, or the headlight is not illuminating. Anything can happen. So if there is a fault condition in a power system, we must know that. We must detect that as soon as possible and try to analyze that fault and remove that fault to bring the power system back to its normal operating condition so that we can supply electrical power to the consumers safely and in a reliable manner. So that's the other point, that we need to learn about the fault conditions. There are various types of fault conditions in electrical power systems, but in this module we are considering only balanced fault conditions. There are some faults that are called unbalanced faults as well. That unbalanced faults will come in power systems 2 in 4th year level. Now, coming to the next bullet point is that understanding and knowledge of electrical and mechanical design of transmission lines of for power transfer from the generating stations to the consumer premises. Like I may have mentioned, the power stations are in general located very far from the consumers or center or the core of consumers. For example, we are sitting here in Durban. It has millions of consumers, but there is no power station in Durban. The power stations are in Mpumalanga. The power stations are in Cape Town. The power stations are in Drakensberg. So we need those we need those transmission lines. And when we design those transmission lines, there are some features or characteristics that must be considered when we design those transmission lines in terms of both electrical and mechanical aspects. So we need to know something for those electrical aspects. We need to know something for mechanical aspects of those power transmission line designs. So that's the bullet point that we talked about. And then we need to know something about the performance of underground cables. It's not that we all the time use overhead transmission line, meaning the transmission lines that we see overhead when we walk across the roads or the national highways, or even at our communities, we see those distribution lines. In the main roads, we see overhead lines, towers. So those are transmission lines and distribution lines. It's not true that we use them all the time as overhead system. We also use underground system, because when we have a very highly populated city, we cannot put them overhead because it's a danger. Electricity gives us many things. It makes our life easy. It makes our life more what word I should use? It makes our life more standard. I'll come to that point again. More standard, or it improves our living standard. So if we have a city where we have very highly populated buildings and people around, we cannot have overhead system. So we use underground cables. And it also has other advantages. Now, I was saying that these are our intended learning outcomes for this module. So from this slide, you can see there are basic operation and economics, and there are the issues of power control, voltage control, load control, and power factor correction, and analysis of a faulty system for balanced fault condition, the understanding of mechanical and electrical design of transmission lines, and understanding of application of underground cables for transmission as well as distribution. Now, I was saying that these are the outcomes of this module, which means we need to learn all of them, and the questions in tests will be set. And if we have exam, we'll have exams questions from all these points. So we have to learn all these and make sure that we really have learned all of them. Like I have mentioned, if we don't know these, we cannot be an electrical engineer, and especially if you want to be in power system where everything is integrated to make a system working and deliver the service to the community. Now, I was coming to that other point, the last bullet point, that the improving the life, or the living standard of life. Electricity actually is one of the indicators. The access to electricity or consumption of electricity indicates how our living standard is. Like if you are using less electricity, meaning your living standard is lower as compared to the people who are consuming more electricity. Does it make sense? You need to answer.
Yes.
Yes. Now I will ask question. You must put your microphone all the time. I can see all the microphones are off. It doesn't make sense. I'm not going to be able to continue my class, not only today, all the time. The microphones need to be on and you need to talk. If we don't talk, then we don't learn anything. So if you keeping your microphone on, off, I cannot continue with the lecture.
The thing is, so you have background noise, so it's gonna just
No, those
disturb the
background
whole
noise need to be
class.
stopped. Those background noise need to be stopped. It's a class. At the end of the day, it's a class. If you can minimize that one, you have to minimize it, because I would need all your inputs all the time. Now, like I have a question now, I need answers from you. So my question is related to what I say. Can you listen to me? And my question, this question is related to living standard of our lives. Living standard, right? We said that consumption of electricity is an indicator of our living standard. So which country do you think has the highest consumption of electricity per person?
So I think it's United States.
If you don't put your microphone on, then I won't listen to you. You can write it on the chat box. If it's too noisy at the background, you can put your microphone off and must answer on the chat. I won't continue unless I get the answers from you. So my question is, what country do you think has its people having a very good living standard in terms of electricity consumption? I see one answer, USA. It's not the answer. Can I have more answer? I need to listen to all of you. No, not Germany.
Good.
Any of the European countries? How many countries are there in Europe? It's not a good answer. You must not answer like that. If you say that I don't know, that's better. South America, it's not. Again, it's something similar to European countries. China, no. No, China, not Switzerland. Russia, no.
Wind.
Why didn't you put South Africa?
Country.
Netherlands, no. You can Google it. You have the Googling facility these days. France, no. Highest, I want something in between 1 to 3 at least. Iceland, that's the answer. Iceland is a very small country. You can Google it. It's a very, very small country. People came to know, many of us, including myself, came to know about that country when they started playing very good soccer. Do you remember that? They were playing very good soccer in Europe. That's why people came to know, many people like me. Iceland is one of the countries that has very, very good consumption in terms of per person electricity consumption. So to give access to everyone to electricity is the target. Target of who? Of ours. Electrical engineer.
Suppliers.
Huh?
The electrical suppliers, so yes, engineers.
Yeah, but electrical suppliers are who?
Eskom in South Africa in particular.
Huh?
Eskom in South Africa in particular.
I couldn't hear you properly. Can you put your microphone volume a little more if you can? Okay, you're saying South Africa? Okay, you're saying ESCOM in South Africa. Now ESCOM is who? ESCOM is just a body. ESCOM means a lot of power station. ESCOM means a lot of transmission lines. ESCOM means a lot of buildings, offices, and all those stuff. Substation, distribution station, and all those stuff. But who actually? I want human being. Like if you say UKZN provides you education, right? Now, if you came to UKZN during this COVID-19, who would you found? How UKZN would you provide? How UKZN would provide you education? You understand what I'm saying? Yes, there is the engineers at the end of the day who are responsible to making it possible. So it's us. The responsibility comes to us. So it's not that we just need to learn, we need to be responsible while operating this system. The reason is that, as I have mentioned, electricity is nothing but dangerous. Yes, it makes our life much better. It improves our living standard, but it's very dangerous. So it kills people in no time. It doesn't give you any warning that, okay, I'm going to explode now. Please stay far away from here. Right? So you see the news on television, in the newspapers, that people touched those hot wires and they were killed on spot. So we need to be responsible for this whole thing, because when we talking about that large power system that we talked about, that we are now dealing with large power system, and this large power system means what in a simple word? A power system means what in simple words to you? It's a large power system. What is there in it when we are operating? Can you give me a word? What is involved in this process of power system operation? I need one word from you. Okay, I'm giving a hint to you. We consume electricity at homes, right? Is that right? Answer, say yes or no. We consume electricity at home, right? Okay, that's good. Now, when we consume, we have to pay to the supplier, maybe ESCOM or Ethiopian Electricity or whatever electricity, right? You have to say yes or no. Okay, that's good. How do we pay? In what way? Like if I go to a grocery store, I buy a kg of potato, they will tell me 12 rand a kg, right? Yes. Now, how we pay for that electricity? How that analogy will? What is the unit, or how we pay for electricity? How much is for how much? In kilowatt hour. That is the correct answer. Now, kilowatt hour is what? Is an unit. It's a unit of what?
Power.
No, it's not power.
Work.
Kilowatt hour. We pay in terms of kilowatt hour. Kilowatt hour is the unit of what? Energy. Kilowatt hour is the unit of energy. So what is involved in this power system is the energy. And now why I have to come to this word energy? Because that is what we are dealing with. And when the power system is large, the energy is more. You can imagine if you put that kilowatt hour into the context now, how do you get 1 kilowatt hour? How do you get 1 kilowatt hour? Answer. How I will know that I have consumed 1 kilowatt hour and I have to pay for that? Answer that. All the time we need answers from you. Give me an answer from the meter. But if you don't have a meter, I'm staying in a place where I have never seen the meter. I don't know where the meter is, honestly. I wanted to see it, but I didn't see it. Still, I know I have consumed 1 kilowatt hour. How do I do that? You must answer. Okay, if you have noise at the background, you put the microphone off and write it on the chat box. You must answer how you know that you have consumed 1 kilowatt hour. Yes, calculating it from the power rating of the appliance, but what else is required? Only power rating of the appliance will not give you the kilowatt hour or the energy. What else is required? What else is required? Look at the unit, kilowatt hour. What are the things that are there? Yes, hour. So it's the power and the time. So if you multiply kilowatt times hour, meaning if you multiply the power rating, meaning the watt or kilowatt, by the time in hours, then you get kilowatt hour. Is that okay? Okay, so when we have consumed some kilowatt hours, like for example at your homes, how many kilowatt hour you consume a day? You give me an idea of from your house consumption. You know what are the appliances that are there in your house. It might be a 1 light bulb or 2 light bulbs or 3 light bulbs, a kettle or a microwave, a refrigerator or an washing machine, a television or a computer. 30 kilowatt hour a day or a month. Is that 30 kalam? Is that 30 per day? Okay, that's a big house, I guess. So your per day 30 kilowatt hour means 900 kilowatt hour per month. So what is the electricity bill that you pay? Every month? How much do you pay for electricity bill every month? Can you answer? That is the ESCOM average. So I need to know the amount that you pay every month as for your electricity bill. How much is the electricity bill that you pay to ESCOM every month? I need answer. I don't continue until or unless I get answer from you. I told you I'll stop 1800. So what is the cost per? We pay about 1500. So if you're saying that 30 kilowatt hour you consuming a day, and then it means 900 kilowatt hour a month. Am I right? So it means if you are paying 1800, it means 2 rands per kilowatt hour. Is that right? Is that right? Huh? That's right. Are you sure? Okay, I pay 3.75 kilowatt hour per day. Can you hear me? Yes. So what is the point I'm wasting time? The point is that you want to be an engineer, electrical engineer, and power systems, that is the module that we are learning, and we want to be a power system engineer. We must know these things. Everything is related. We can't claim ourselves as a power system engineer and we don't know what is happening even at our homes. What is happening to the next door? Who is consuming my electricity where I'm working for ESCOM or say Ethekuni Electricity? Does it make sense? They will laugh at us. Do you understand that? Yes, thank you very much. So you need to know everything about that. All the information that you collect will make you a better engineer, and that is what I want. And we talked about who are responsible, the engineers. The reason is that engineers are the ones who make the nation. If you remember what was happening just at the inception of COVID-19 situation, they were looking for what? One item especially they were looking for, not the vaccine. What else they were looking for when COVID-19 came into the scenario? Give me an answer. What was the thing that the medical fraternity was looking for when COVID-19 came into the scenario? What special thing they were looking for? Any answer you can write. It's not a problem if the answer is wrong. We all learn. No, I so told that it's not the vaccine. Ventilators, yes, that's the correct answer. And who make those ventilators? It's the engineers at the end of the day. So engineers are everywhere. So my point is that be an engineer who can have an impact in the society to save people's lives, to make people's lives better. Like we talked that with electricity, we can make people's living standard better. So you need to collect all this information all the time, and it's changing. So you need to be on the system all the time. Okay, I'll raise this type of questions many times. It's not wastage of time. It's not wastage of resources, but it will make us more knowledgeable in this area. There are many things that you need to know. So I'm coming to the next slide, which is on the assessment. Can you see that one? Okay, now as this COVID situation we are in, we have this class mark is equal to final mark that we have seen in first semester as well. Now we're coming to the same thing. Class mark will be equal to final mark, and we'll have practical and tests. We'll have 20% from the practical, and it will be simulation studies. Dr. Tiako is the course coordinator for this power system. I'm a lecturer for this part that I'll come later on. So Dr. Tiako will deal with the practical simulation stuffs and also his section of lecturing the modules. I am responsible for the part 1 or section 1, and in each of those sections we will have tests. So we will have 2 tests for each section, meaning there will be 4 tests in total, and those 4 tests will give you 80% mark for the class mark, and 20% will come from practical. Is that clear? Okay, that's great. Thank you. Let me go to the next one. Now, practical, we don't have any exemption in this module. Meaning what? If you did this same module for Systems 1 last year, and if you passed the practicals, now you re-registering for this module this year and you want to get an exemption. No, we don't have. You have to redo. Meaning this year you'll have to do the simulation study and get a pass. So there is no exemption from the practical in this module. Now I'm coming to the test dates. Like for me, I will be lecturing part 1, and I will have 2 tests. Those test dates are mentioned here. Online test, the first one is on 12th of October and the second one is on 2nd of November. Both of them at 10:30, meaning on Monday. You can check the dates. If I'm wrong, you must let me know. So the timing of the test is from 10:30 to 12 online. It's already set on the module. I'll show you the module setup just after this slide is over. It might not be possible today because I can see that I lost 15-20 minutes in the beginning. Now it's 12:30. So those 2 test dates are from me, 12th October and 2nd of November. Dr. Tiako will announce his dates. I'm not sure if he has announced already or not. Now, we are very good at falling sick on the test date, are not we? We know how to fall sick when there is a test that we have to write.
Yes.
Yeah. So if you want to fall sick on that day, it's fine. We have all the rights, freedom, and choices and all those things to fall sick on the date of test. So what you need to do if you want to write a makeup test, you have to bring a medical note from a doctor, registered doctor, and submit that to me and let me know that you want to write a makeup test. So if you don't do that, meaning if you don't bring that medical note and if you don't tell me that you want to write a makeup test, there will be no makeup test. If you want to do so,
what about things like load shedding?
There is no such thing. When I'm saying there is no such thing, it means we should not just bring excuses. We know that there are load sheddings. You don't need to mention, like the other answer, if you any country in European continent or African continent, this question is something like that. What if you had load shedding? Didn't you have load shedding in first semester? Was there any load shedding in first semester? How did you write those tests? How others wrote tests during the load shedding time?
They gave us more time, like they stretched the times, maybe from half 10 to 12. They say from 10 to 4 it will be open, but we have 2 hours to write. That's what they did.
Yes. So similar things will deal with that. Is that okay?
Yeah, that's fine.
Yeah. So we'll deal with those kind of things that comes in scenario. So we, like I mentioned, that there will be load shedding, the computer will crash. All the computers crash when you're writing test. They don't crash at that time. When I'm playing games or when I'm watching movie, when I'm listening to music, they don't crash. That's how the computers are. They know that we are writing a test, so it must crash now. That is very important to note. So if you want to write a makeup test, you must let me know. And this DUP requirement is somehow complicated these days. But what you must do all the practical, because that is something very important in terms of power systems operation, because if you don't do practical, maybe simulation is still okay because of the situation, but you must do that because that is one of the greatest opportunity to learn something. Because if we don't get ourselves engaged in that process, we don't learn. We might have read many books, we have learned many theories and how to apply them, but we have not applied them in the practical. So we have not completed the process of learning and understanding fully. Do you agree with that? So you must do those things very seriously, not just meeting the minimum requirement. Minimum requirement will put you in those rows that will be labeled as minimum requirement row. And with that, one never ever can excel. Right. So you must take the practical very seriously all the time. Now this examination is out of the scenario now, but we don't know, things might change. Like we have seen from the month of March, it has always been changing. And we are here today in the month of September. So we'll see if there is exam, will come, we'll deal with that. And if there is no exam, the class mark is final mark that we have explained earlier. And these are the course periods that you know from the timetable. Can you verify if I wrote it correctly? Monday, Tuesday, Wednesday, and Thursday. Can you verify and say yes or no, correct or not? Okay. Now the thing is that Monday is at 10:30 to 12, 10 past 12, and today I'm not able to take a break because actually you got a break before I started, I guess maybe a few minutes. But what I normally used to do, I used to give you a break in between because it's a double lecture session, and sometimes I continue, but I will let you go before or around 12, 10 minutes extra break in between two classes. It depends on how that particular day is. Is that okay with you? Yeah, I'm coming to the next one, which is a Tuesday, 7:45. It's a very challenging thing to us to wake up early in the morning and then open our computer or sit in the class and listen to it, isn't it? Yeah. So what will happen if you miss, you miss. And it's an opportunity. The reason why I'm mentioning these things, all of you who are listening to this have registered for this module. Am I right? What does that mean? How did you register? I'm not asking for online or offline or on site. Somebody help me to register. What did you have to do to register for this module? You paid. That is the answer that I looked for. Thank you very much for the answer. Meaning you paid, and it was a lot of money, in my opinion. It's not like 2 Rand or 5 Rand or 100, right? And then you don't want to take the service from it. For example, you can imagine I went to a Nando's, then I ordered a food like chicken, a nice chicken, 200 Rand with nice sauce and everything. They charged me 200 Rand, I paid, and then I don't collect. Does it make sense? Okay, what kind of activity will it be? If I did something like that, I paid 200 Rand at Nando's by ordering a nice piece of chicken for me, and then I don't collect it. What would you call it? The activity, what would you call it? A single word can describe it. What would you call it? You can have the word. So it's fine. So try to make an effort to listen to, because what we learn in this module is not just for getting a pass in this module, making up 25% of your 64 credit module that you have registered, that I mentioned earlier. It's the opportunity to learn, and after graduation you will be able to deliver what is required for the community, for the nation, because you build the nation. The same applies with the other ones as well. Thursday, 1:15 to 2 o'clock. Now let me go to the next slide. Past test questions. I have put questions on the website, Moodle website already, so you can check it from there and you'll get some idea how the questions are. This year we will have more theories on the question paper that you should expect. The reason is that the scenario is changed. You were writing test in the classroom or in the exam halls. Now you are writing at homes. Right, so we'll have some more theories and how you have understood all those points that we have discussed in the learning outcomes. So the question paper will be on the Moodle website for you to access and write, and submission will be on the Moodle website as well. So past question paper you must check. And I'm coming to the laboratories. Normally we did this practical in this missionary hall, but there will be no practical simulation studies, but the practicals remain the same: three-phase circuit measurement and energy metering. And if you remember the word I was talking about, the word energy is very important. So we're dealing with energy, and the large power systems have large amount of energy involved in it. And the measurement, for measurement is very important. Many of our students in electrical engineering I have seen and I have come across over the years, not only here in South Africa. I'm originally from India. I also was involved in teaching and learning in other 3 institutes before I come here. The students don't have much idea about measurement. When we talk about operation of a power system, when we talk about control of a power system and its various parameters, before we go to that, we need to measure them. Like we talked about kilowatt hour, right? We need to measure them. Then we talked about the meter. That meter is actually measuring how many kilowatt hours are being consumed over a period of time. There are other parameters that we know. Those are very well known. Current, how do we measure current? There is voltage, how do we measure voltage? There is power, watt or kilowatt, how do we measure them? So that measurement part is very important. And unfortunately, we have a module here at UPZN in electrical engineering measurement, but that is not on offer. So what you must do, actually, you must study a little bit at home when you have free time. Your mind is relaxed, to take some opportunity to get into the measurement procedure, how current is measured, how voltage is measured, how alternating current is measured, how alternating voltage is measured, and how direct current and direct voltages are measured. There are different instruments, we call them measuring instruments for measurement of various parameters. We have something, you have heard of that word as well, frequency. When it comes with alternating current, how do we measure frequency? How do you measure impedance? How do you measure your resistance of a resistor? All those things, we have to measure them, right? So that measurement, the reason why I'm spending time again here is important. So you must make sure that you know something about the measurement. And this measurement that you were supposed to do it in this machinery hall are still related to low voltage, like 380 volt. Sometimes we also work with 220 volt. So those measurements are at very low voltage. But if you go to that large power system that I was referring to, that it is coming from the power generating stations from Mpumalanga or Cape Town, Kubag. They operate, the generators operate at very high voltage, 11,500 volt or 17,500 volt or 15,500 volt generators are operating at that tens of thousands of voltages. But if you come to the transmission line, the voltage is even higher. It's 400 kilovolt, meaning the voltage is extremely high. We have also 575 kV voltage level. The research in transmission line is going to the level of 1000 kilovolt. So how do we measure them? So we need to learn something as well in that regard. Right, so you will spend some time in measurement. Now safety is very important, like we have been hearing that we might be coming back to campus. It's very important for all of us, regardless of anything, regardless of any parameter you might use for whatever reason, but it's important for everyone, for everyone literally. So you keep observing the safety rules and regulation all the time for yourself and others. This is very important thing. Will you do that? Now I'm coming to something to my section now, is that book. The book that I refer to is that Stevenson Granger, Power System Analysis. It's a publication from McGraw-Hill, and that book is available in the library. Some of you might be able to come, but the other book I have is also from the library. It's written by Wadhwa. The book is called Electrical Power Systems. It's from Will Easton publication. And you are allowed to use any book that you think is standard and is suitable for the Power Systems 1 section 1. And for me, I have listed these two books because I found these two books are very good. There are many other books that are also very good, but in South Africa, what I found that books are very expensive in South Africa. So I didn't put other books, and I would prefer, if you are in power system, then you can buy this book. If you don't want to be in power system in future, for example, sometimes some of you might have an interest in going to high voltage engineering, some of you might want to work in machines area, then you don't need to probably consider to buy a book, but having a book is good. But for my sections in Power Systems 1 module, the notes that I have put on the website, Moodle website, are good enough for this module to learn, because I have consulted about 12-13 books to write those notes and other documents to put them in different chapters. So for this module, if you just want to pass this module, like we know that many of us, we just want to pass this module. Am I right? We don't worry much. I just need to pass this module. Is that right? You should answer. Do you agree with me that there are many of us who just wants a pass from this module? Yeah, and it's even more interesting when I find that if there is a student who gets 51 and there is a student who got 50, the student who got 50 is more excited than the student who got 51. So if you want to get a pass, you definitely can get a pass from the notes that I put there. Not only that, you can actually get 90, 95 as well in the module. The students who used to learn in Power Systems 1 and Section 1, they get very good marks and they learn a lot, and they apply those what they have learned in this module in their master's degree and in PhD. Like I've been teaching this Power Systems 1 module layer at UKZN since 2009, and over the years many students found these Power Systems that I offer are very interesting. They came to me, they did their projects with me, and then also they did masters, and they're doing PhD with me as well in Power Systems topics. There are many good things in this section, so you can learn as much as you want. And apart from that, I wanted to mention another thing. When we talked about the marks, that there is an award. I'm not sure what will happen this year or next year, that we give to the students, the best power student, the best Power Systems student, meaning the marks that we get from Power Systems 1, Power Systems 2, and Power Systems Stability module, we combine them, and then we find the best student, and he will be awarded as the best Power Systems student. So you must know it from today, that if you score very good in Power Systems 1 and 2 and Power Systems Stability, if we offer it, then you have a good chance to establish yourself in Power Systems and get that award. So keep that in mind. Now I'm coming to that other part that I mentioned, that I'm doing the part 1. I'm just a course lecturer, but Dr. Tiako is going to be the course coordinator, meaning all the course related things will be dealt by him, including practical sessions. And I'm lecturing this part 1. Dr. Tiako is lecturing part 2. For me, I used to sit at electrical, electronic and computer engineering building in room number 308, where you can find me, but I'm also sitting at the Unite building because at the moment I also have been given an additional position at the School of Engineering, which is the academic leader of research, meaning assisting the dean with the research part of the whole school. And whole school means it includes electrical, electronic, computer, civil, mechanical, agriculture, chemical, everything. So I'm dealing with that part. So I sit in 2 rooms, but mostly in room number 38 at the Unite building. But these days the room is not that relevant, but what I want is that whenever you need anything, communicate to me via email, and then we can solve all the problems. Literally, we can solve all the problems if you are willing to. If you are willing to listen, if you are willing to do whatever is required. So whenever you have any problem, and when I'm saying any problem, meaning I literally mean any problem, because over the years people came to me, meaning the students, the colleagues of your class, they come to me discussing the personal, very personal issues, and fortunately I managed to solve them in one way or the other, and they were sorted out, and they improved their lives. Many were stuck in various difficult situations, apart from learning of Power Systems 1. That is what I'm referring to actually. So whenever you have some problem, you can talk to me. Whatever it is doesn't matter, and whatever you tell me, I don't discuss those things with others. That's why I'm not telling you anything in details, but just putting in general, that personal, whatever it can be. So you come to me, but email me. Please use that email address, email me, and then we'll sort it out. I'm going to go to the learning website now. Just hold on with me for a few minutes. I have something more to discuss here, but I will discuss them later on with the course outlines and everything later on. But one thing I want to show you is the house rule. Can you see the house rules?
No, sir.
Can't see. Can you see now?
Yeah.
House rule means like those background noises and whatnot and all those stuffs. So you must make sure that we are sitting in a classroom, although we are at home. So the other word that I'm going to use here is the respect. We must respect that it's a class. Right, that's one of the things. And then the second thing is that when we come to especially the tutorial sessions. Like I will be doing the lectures, and when one chapter is completed, I will do the tutorial. I need you to have your calculator and the exercise book with you all the time. You will be required to calculate and give me the answers. So you must be ready with your calculator all the time, the scientific calculator, not the calculator from your cell phone. Or if you have your cell phone, very nice scientific calculator, it's okay. If you can calculate all those rectangular, exponential and all those stuffs, it's fine. Log, it's okay with me. But I need that answer from you all the time. So that is one of the things. And then I will ask you many questions, many times. And when I ask you those questions, you don't answer. Some of you answered today, many did not. Now, what is the advantage and disadvantage of that? The advantage is that we learn when we answer. Like someone said China. China was not the correct answer. So what was the correct answer? Was that Iceland. Now you answered it and then we know. But if we did not answer, I might be sitting with that answer China all my life. Does it make sense?
Yes.
Unless I answered, I wouldn't know that it's wrong. Unless I answered it, I wouldn't know that my answer was correct. So you need to answer. And when you answer those questions, one thing I do, this is unofficial, is unprocedural. But what I do is that I take your answers. I remember who answered what. Although I'm not seeing you much on the because of the screen thing, but if it was in the class, I would have been observing you in a more prominent way. How you answering, what you thinking, what you are not thinking, and all those stuffs. So I take those answers very seriously. Although it's unofficial, it's unprocedural. But what I do with those answers, I take them when I am going to mark the tests. Remember, we said that we'll have 2 tests from my section. So when I'm going to mark those sections, if I find that you made just a mistake, maybe you are rushing to submit it on time, maybe you forgot, you missed a very simple thing, but I know that you gave me the correct answer, that Iceland, that country. You gave me the correct answer of kilowatt hour, for example. So I'll take those correct answer and I'll give you marks in the test. 1 or 2 marks. For that 1 or 2 marks, someone will pass. For that 1 or 2 marks, someone will get PM, certificate of merit. Does it make sense? It makes a huge difference, especially those who will be probably sitting with 47, 48. Do you understand that?
Yes, sir.
Yeah, so whenever I ask questions, those are very relevant questions that I will be asking from general understanding, from applications in power systems related to the chapter that we will be discussing or learning. All those questions, answers, I will be taking into account and will give you marks, not for deducting marks. If you gave me a wrong answer, it's fine. I will not deduct mark from your test. But if you gave me a correct answer, you will get 1 extra mark in whatever way it's possible. If you missed something, I would like to give you marks all the time. So I take this opportunity to give you marks. So those are the kind of things. And the next thing, which is the most important thing, you should ask questions as well. I am going to ask you a question. I have asked you a question today. I'm going to ask you a question every day. You will have to answer those, like I mentioned, but you have to ask questions, because if you don't ask questions, you never learn. Right? You ask questions and I will try to answer them, and I'll be very happy if I find that question that you have asked, I can't answer that one. I want to have that kind of question that I cannot answer when I'm talking to you. I will have to find out the answer, and I will find out the answer and I will tell you that this is the correct answer. If I have to read 20 pages to find the answer that you are looking for, I would have to read that and then write a page to answer that. and I'll give it to everyone so that everyone learns at the same time. Remember one thing, everyone in the community is important. No single person can live on his or her own. No single person can do anything on his or her own. Right? So everyone is going to ask questions all the time. So I'm going to the next one now. Pass fail, like I mentioned that I used to give you marks. I try to give you marks whenever it's possible. I do not want you to fail at all. Not only in this module, not in any other module at all. You must pass all. So that is the aim that you should set up from day one, meaning today, that you must make your time and effort. These are the two things that I always emphasize on, that you must make your time and effort to make sure that you pass. We don't want to fail. But if someone is getting a fail, still it's because of the rules of the university, rules of the academic institution. There is a fail for certain minimum criteria that we talked about. So make sure that you put your time and effort to pass all the modules. We don't want anyone to fail. I want everyone to pass all the modules. Now I'm coming to the next slide. Can you see that applications of knowledge is acquired? Can you see the slide?
Yes, sir. Yes, sir.
Yeah, this is one of the most important thing when you come to power systems. Like I talked about that high voltage, you might be testing some installation of a generator, transmission line, or a motor. You might be testing something in the generator itself for it, because generator is a machine. So in that machine's theory, you might be learning something. But when you come to the power system, you need to apply all of them. Because you can't have a power system without a generator, without a motor, or a transformer, or a transmission line, or this is an integrated system where everything is connected and where everything is related. Do you have a lecture after 10 past 12? Okay, I want to show you these things. I'm not sure if I have shown you earlier. Do you remember this kind of things? Somehow. This triangle with A on each side. Have you seen something like that?
Yes, sir.
When? Where? Was it me?
Yes.
Okay, that's great. So what I just want to show you one with a, like I used to do these things when I was in grade 7, grade 6, that I made triangles with every letter of the alphabet and I put it like this: A, attention, attitude, and attendance. So you have to attend the lectures, you have to be attentive, and you have to have the attitude to learn all the time. Then only you can excel. If you take out any of these three sides or any of these three words, nothing will happen. You can just imagine, if you are not having the attitude of learning, but you are attending the session, nothing can happen. If you are not attending, nothing can happen. So it's something like that. It's very serious, and it worked for me. And I always have been like this, that whatever I found worked for me, I always give it to the students so that they can make their things better, they can make their lives better. So you must always remember this. And I'm going to go to the Moodle and show you those things that are set up there. Give me just 1 minute. So that I can show you what is there on the Moodle. Can you see the page?
Yes, sir.
Yes, sir.
Okay, now from tomorrow, I'm not going to use Meet Teams at all. I'm going to use this online class. section 1, in case I have this online class, can you see that it has changed to that hand symbol? If you click on this one, it will open up with something called join the class. Once you start joining for the first time, it will ask you for the Adobe Flash Player. You just say yes, and then it will ask for microphone, this and that. All the time you say yes, 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 and then you will join. And for example, it will look like this. I'm clicking on this, and then it says join session. And then if I click on this, and as I have already done, click enable to Adobe Flash Player. Just click it and then say allow. And then it will continue. And it will open the screen like this. It will load. And you can test your microphone for your testing.
You are
Okay.
currently the only person in
And
this
then you
conference.
say okay. And this is where I will put my PowerPoint. Let's say default power. I'm selecting that one. Let's say course outline power system. That is my part, but what you will see is here. You understand? Can you see what is on the screen?
Yes, sir.
So your names will come here on the left hand side where you see my name. You will join here all the time, keeping your microphones on. And this is what I'm going to use for lecture session. The reason is that it saves data because we have a GB free every day, 500 MB for connecting to internet, and then 500 MB on the UKZN URL. Am I right?
Yes, sir.
So that will be saving our data, especially your data, because I run out of data every month. So it will also save your data. I used it in first semester for all the module lectures and everything. So I'm not going to use the Teams or Zoom unless I have to. If it is not going to work after December, it's not going to work because the Adobe Flash Player is going to be obsolete after December. So until December, let us utilize this opportunity to save some data every day, because we have 5 lectures every week. It's too much data that will be consumed. So when you are done, we just can close this one, go on back, and we can go to the session. Now, after online class, you have the attendance register. So you'll have to do your attendance here every day. You go and do that attendance register. This is the course outline that you can read. That was put by Dr. Tiako, and these are my section notes. It has 5 chapters that you can see: Kelvin's economy law, second tension, symmetrical fault tendency, transmission line parameters. I will talk about those things tomorrow because we have already reached that 10 past 12, and then I have a formula sheet. I will talk about that tomorrow. And then I have this test paper that I told you about, that passed from 2018 and 2019, 2 tests 1 and 2, and so on. And this is my section where you will do your test submission, meaning it will come on when you click on it for the submission. As you can see, the 12th of October and 2nd of November from 10:30 to 12. I gave you 5 minutes extra for submission. Up until 12 you will write, and after writing you have 5 minutes to submit. After that it will close itself. It will not accept anything. Is that okay?
Yes, sir. Yes, sir.
Okay, and when you are done, we will do the course evaluation later on at the end of the semester. When I'm done with my section, I will do that later on. I will start with the lecture outline tomorrow, meaning I will give you what is inside these chapters, each of them. Then when I'm done with that, I will start with the Kelvin's economy law. But before that, I will start with something, I call it introduction, because one of the reasons is that I told you that we are now going to deal with a real power system, large power systems that are practical power systems. It's no longer a fictitious thing, no longer just reading some theories from books and doing some calculations using some calculators. No, we are going to deal with the large power systems in a step-by-step manner. So what I'm going to do is that I'm going to give you an introduction, because what is currently happening is that what we have in our power systems 1 module and what we have in our real life power system, there is a huge difference. The gap is too much between what we learn here in our Power Systems 1, 2 and Power System Stability modules and what we deal with in our real lives. Huge difference. So what I do, I used to take this opportunity every time I get as such to bridge the gap as much as we can. And for that, I give some extra introduction to each and every chapter. And that extra introduction is from the real industry. But most importantly, like we said, we are happy to get just a 50. We don't want to worry much. That is why I don't ask any question in the test from that extra practical or real power system lecture. So that is for you to learn and know more. I will not ask any question from those sessions, but those are full of practical examples of power system operation, maintenance, control, protection, automation, everything. I'll come to those things in a step-by-step manner as it comes. I take this opportunity to thank you very much for listening to me, and anytime, anything, you can always communicate to me.